Dr. S. Venkatesh, Public Administration. డ్రాప్ చేసి వచ్చినా రాజు గారు డ్రాప్ చేసి వచ్చినా ఎక్కడ
పబ్లిక్ యాడ్ వెంకటేష్
ఇంకేనా మర్చిపోయినా చూసుకో వాటర్
ఎందుకట్లా అయినది ఓకే వచ్చింది కదా
నేను ముందే అయిపోయినా ఇంకేం తీసుకురా ఒక్కొక్కటి ఏ కీసాయి
Today we are going to discussing black tree synthetic strategies. So this black deals with the synthetic strategies. There are 5 units in this block. One is unit 11, introduction and target selection and terminology. Unit 12, disconnection approach with examples. Unit 13, carbon-carbon disconnection. Unit 14, applications of some important strategies in organic synthesis. Unit 15, amine synthesis, consecutive and convergent synthesis, and some selected syntheses. First, we are going to discussing introduction and target selection and terminology. Target selection. Molecule to be synthesized is called target molecular target. The target molecule may have a challenging stereochemical structures, functional groups, binding
జువాలజీలో సిద్ధయ్య వచ్చాడు
combination or many
ఇంకా రాలేదు
process.
జువాలజీలో సిద్ధయ్య వచ్చాడు, కెమిస్ట్రీలో మురళీకృష్ణ వచ్చాడు, బాటనీలో ఎవరు అన్నారు?
Selection of a target molecule is an organic synthesis. Selection of target molecule is an organic synthesis. Synthetic projective mainly depends on several factors. Five criteria are usually considered in the selection of target molecule. These criteria mainly depends on the requirement of the target molecule. Target molecule. Target molecule. First one is structural verification. Structural verification. Some of the compounds having good biological activity, but the percentage of yield is very less. Such type of compounds are taken as a biological target molecule synthesized in large amount. For example, periplanon B is a hormone which is released by Periplaneta americana cockroaches. So these cockroaches, about 75,000 of these cockroaches releases 200 micrograms of the compound of this periplanon B. This compound is not sufficient to the to determine the structure of the structure and stereochemistry of the molecule. Therefore, this type of the compounds are chosen as a target molecules. Next one is biological activity. Some of the compounds are shows good biological activity and 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 their percentage of yield are very less. Type of the compounds are taken as a target molecule and synthesized in laboratory. For example, prostanoic acid is a prostanoic acid is a good biological activity compound that the percentage of yield is very less. To this type of the compounds are chosen as a target molecule synthesized in large amount in laboratory, and also good biological active compound and the percentage of yield is very less. Analog studies. Some of the compounds are shows very good biological activity and also shows some side effects. Therefore, this type of the compounds are taken as target molecule. Therefore, this type of the compounds are taken as a target molecule to increase their biological activity and decrease their or minimize their side effects. Um, uh, Side effects and synthesized in laboratory. For example, penicillin is a good biological activity compound, but there this penicillin shows some side effects to the some peoples. Therefore, this penicillin, aloxar, amoxicillin, and ampicillin are the good biological active good antibiotic compounds, and they shows more potent than that of penicillin. Topological studies. Topological studies means a study of the structure of the molecule is called topology. Some of the compounds are good biological active and their structure is very uh, complex. Therefore, this type of the complex molecules are chosen a target molecule and synthesized in laboratory. For example, here dodecahedron, cubine, propylene. Next one is next one is new reactions and new reagents. Sometimes in a synthesis, synthetic organic chemistry come across a problem, even come across a problem to to achieve some protein chemical transformation. For example, in the total synthesis of vitamin B12 by the Woodward, a key step was hydrolysis of amide functional group in presence of 6-ester moieties. The hydrolysis was very difficult to achieve about without affecting ester moieties. Therefore, a new reagent was required which could hydrolyze only amide function group without disturbing ester function groups. After considerable amount of such a new reagents and chloronitron figure 11.4 was developed which could strictly hydrolyzed amide functions. So whenever existing reagents are not able to bring about the required transformations, development of new methodology or modification of existing reactions will have to be carried out, thereby producing a new reagents which can becomes useful in similar other process. Retrosynthetic analysis. Retrosynthetic analysis is a problem-solving technique in which the target molecule is transformed into precursor structures. Each precursor is examined using the uh, some some methods, and the product produced is repeated until a unit is simple or commercially available starting precursor is reached. The goal of regiosynthetic analysis is structural simplification. The synthesis of any compound can be achieved usually by more than one synthetic route. Retrosynthetic analysis is a synthetic study suitable for planning various possible synthetic routes to target molecule. Then all the possible methods are compared and studied for selecting the most appropriate route by considering the availability of starting materials, reagents, yield in the each step and functional aspects. Terms used in the retrosynthetic analysis. Terms used in retrosynthetic analysis. We come across many important terms in retrosynthetic analysis or in designing a suitable synthetic strategies. There are one is target molecule, final molecule. One is attempting to synthesize in a given synthetic project is target molecule. Functionalization. Functionalization. Introduction of a functional group into suitable molecule is known as functionalization. For example, benzene undergo nitration, then gives nitrobenzene. The nitro function group introducing on benzene takes place, and when methoxybenzene is undergo formylation with DMF POCl3 gives 4 methoxybenzolate. The benzolate function group is introduced takes place. These are the functionalization and functional group interconversion. Conversion of functional group from one functional group into another functional group is a functional group interconversion. Function group interconversion FGI. Conversion of one functional group into another functional group is called functional group interconversion. For example, here toluene undergo nitration then gives paranitrotoluene. This paranitrotoluene under reduction gives paramethyl aniline is the product. Here nitro function group is converted into aniline function group. Disconnection. An imaginary or an imaginary break down the covalent bonds in a target molecule is called disconnection. An imaginary break down the covalent bonds in a target molecule called disconnection. After disconnection, we are getting a charger fragments. These charger fragments are called synthons. Synthons means after after hypothetical or imaginary breakdown the covalent bond in the target molecule, then we are getting a charger fragments. The charger fragments are called synthons. The synthons are two types: positive synthons, negative synthon. Synthetic equivalent. These are really and commercially available species. They carry out the function of synthons. They carry out the function of synthons, and these synthons are readily synthetic equivalents are readily available in the market. Then they gives synthetic produces synthons. Here we are discussing some synthon and synthetic equivalent. Nitrosynthon synthetic equivalent is HNO3 and H2SO4, and acyl carbocation. Acyl carbocation synthon is synthetic equivalent acyl chloride LCl3. Pharmyl carbocation carbocation is formylation reagent. Carboxylic acid synthetic equivalent cyanide, carbon dioxide, and tertiary alcohol synthetic equivalents is aldehydes are ketones, and beta positive carbonyl compounds are beta carbocation of carbonyl compounds are alpha beta unsaturated carbonyl compounds, and alpha positive alcohols, beta positive alcohols with respect to alcohols, beta positive is epoxides, carbocation synthetic equivalent is alkyl halides, and so carbon ion synthetic equivalents are the organometallic compounds like Grignard reagents. Transform it is it is exactly reverse to the synthetic reaction. Transform is exactly reverse to a synthetic reaction. So we are giving transform is giving the naming in the retrosynthetic analysis. In this case, the nitrobenzene undergo retrosynthetic analysis gives benzene. The name of this reaction is called nitration transform, and here the product obtained in disulfide reaction undergo reverse retrosynthetic analysis gives dienes and dinophiles. This is the name of the reaction is called um, disorder transform. And some of that epoxide is converted into alkenes. That is a epoxide transform, and diols. One comma two diols are converted into alkenes. This is called dihydroxylation transform. Return. The part of the molecule which is the subunit of the molecule which is kept for the retrosynthetic analysis is called the subunit of the molecule which is kept for the retrosynthetic analysis is called uh, retra. In this case, your example cyclohexene. In this case, cyclohexene. that that these bonds are undergo the deals are the react retro deals are the transformation. They gives dienes and enophiles. And retrosynthetic analysis of phenylistic acid. In this retrosynthetic analysis of phenylistic acid, the bond between acetic acid carbonyl and phenyl attached carbon undergo retrosynthetic analysis, then gives benzyl carbocation and carbon dioxide. This benzyl carbocation is synthetic equivalent is benzyl bromide and carbon dioxide synthetic equivalent is sodium cyanide. Now we are going to synthesis of this molecule is when benzyl bromide reacting with sodium cyanide, then gives benzyl cyanide, benzyl cyanide, but this benzyl cyanide under hydrolysis then gives benzoic acid the product. And different strategies for the retrosynthetic analysis. Different defining various strategies, transform based strategies. These strategies are based on identifying powerful transform for a specific target which gives maximum simplification. Different transforms are different different transform can be repeatedly applied to result in a maximum simplification in the retrosynthetic direction. So in this 1,5-dic first example is 1,5-dicarbonyl compound undergo Michael transform, uh, then gives phenyl methyl ketone and methyl vinyl ketone, and this indole undergo Fischer indole transform, then gives phenyl hydrogen, para-toluene, para-methyl phenyl hydrogen, and carbonyl compounds, cyclohexanone. And second one is structured goal strategies. These strategies depends on the identification of a potential starting material, building blockers, and synthetic subunits. So in this molecule example, so we are getting three compounds. So from this, we can easily synthesize the target molecule. Topological strategies. Topological complexity is depends on the degree of connectivity. Heterosynthetic simplification. Topological complexity depends on the degree of connectivity. Retrosynthetic simplification is in this kind of strategies involves no ring bonds or ring bonds in the spiro fused or bridged ring synthesis systems. For example, performing disconnection for a for figure 11.56 or stereochemical strategies. Stereochemical studies are mainly aimed at the reduction of stereochemical complexity in a molecule. They remove stereocenter in a retrosynthetic direction for reducing complexity. The they take a advantage of synthetic screening or performing to a functional group. Functional group orientation strategies. These strategies utilize the role of various functional group interconversions, additions, and removal methods for retrosynthetic simplification to a target molecule. In this case, the target molecule undergo functional group interconversion from ester to acid, and second step to third step, that amine is converted to nitro, third to four carboxylic acid converted to toluene, methyl, and fourth to last starting material. Then nitro is elimination takes place. Disconnection approaches with examples. Disconnection approach. Disconnection approach is an important analytical method in the designing designing appropriate synthetic route for a variety of organic target molecules. Retrosynthesis is an imaginarily reverse process of for designing the synthesis of the target molecule. The real synthesis of a given compound starting from a precursor molecule consisting of a series of chemical reactions using appropriate reagents and experimental conditions in each step. For example, synthesis of para-bromoaniline from benzene involves in the 5 steps as shown below. When benzene undergoes nitration, then gains nitrobenzene, and the reduction of this nitrobenzene to form aniline. Aniline undergoes acylation gives N-acyl aniline. This N-acyl bromination takes place para-bromo N-acyl aniline. Then hydrolysis para-bromo aniline will be formation takes place. This is the retrosynthetic analysis of para-bromo aniline. When para-bromo aniline undergo retrosynthetic analysis, then gives um, uh, para-bromo N-acyl aniline. When undergo debromination, next in acylation aniline and nitrobenzene, and benzene will be formation takes place. And ethers undergo retrosynthetic analysis, then gives alkyl positive or RO minus will be given. It is based on the substitutions present on ether. Of aromatic compounds. Retrosynthesis of benzocaine. When benzocaine undergo esterification transform, then converted into para-amino benzoic acid. This para-amino benzoic acid undergo reduction transform, then gives para-nitrobenzoic acid. Para-nitrobenzoic acid. This undergo oxidation transform, then gives para-nitrotoluene. This para-nitrotoluene undergo nitration transform, gives toluene. Synthesis of this benzocaine involves from nitrobenzene. This nitrobenzene undergo reduction with HNO3 and H2SO4 paranitrophenol. This formation takes with this paranitrophenol undergo oxidation with KMNO4. This methyl group on attached benzene is converted into acid, paranitrobenzoic acid, and reduction with the palladium, carbon, hydrogen. The nitro is reduction takes place. Then paraminobenzoic acid. This paraminobenzoic acid reacting with aniline and ethanol in presence of acid medium. Then gives benzocaine product will be formation takes place. Next one is retrosynthetic analysis of paramethoxystrofenone. This paramethoxystrofenone undergo acylation transform. Then methoxy benzene will be formation takes place. This methoxy benzene undergo alkylation transform, then gives phenol. When synthesis of this paramethoxystrofenone involves from phenol, when this phenol undergo methylation with the DMS, then anisole methoxybenzene formation equals this methoxybenzene under acylation gives 4-acyl 4-methoxystrofenone will be formation takes place. And retrosynthetic analysis of 2,6-di tertiary butyl 4-methyl phenol. This 2,6-di tertiary butyl 4-methyl phenol undergo Friedel-Crafts alkylation transform, gives paramethyl phenol. This paramethyl phenol involves reaction with 2-methyl propene in presence of acid medium, then gives 2,6-di tertiary butyl 4-methyl phenol will be formation takes place. Next one is retrosynthetic analysis of 2-bromo 4-methyl phenol. 2-bromo 4-methyl phenol undergo diazotization and hydroxylation transform, then gives 4 2-bromo 4-methyl aniline. It is undergo hydroxylation transform, then gives 2-methyl 2-bromo 4-methyl N-acyl aniline. And it is undergo acylation transform, then 4-methyl aniline. It is undergo reduction paranitrotoluene, and it is reduction titration transform toluene will be pharmaceutical. These are the steps involved in the synthesis of 2-bromo 4-methyl aniline phenol. Retrosynthesis consists of trifluoralin B. This is the retrosynthetic analysis of trifluoralin B. The order of events and synthesis of aromatic compounds. When a function group interchanges guideline 1, consider the electronic effects of the group already present on the ring and its directing influences. Then choose the disconnection which uh, gives right orientation. For example, in the analysis of para isopropyl phenyl methyl ketone, disconnection of E and B is possible, but 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 disconnection of A is isopropyl group is precursor. Isopropyl benzene is right ring activating group.
and para orthopara directing group, whereas in disconnection B, the acetyl group in the precursor estophenone is the deactivating and also and also meta directing group. Therefore, disconnection is the most appropriate one. And guideline two and guideline two when both electron withdrawing and electron donating groups are present on the aromatic ring, disconnection the most electron withdrawing group first. In other words, electron withdrawing groups are introduced in the first last step of a synthetic sequence. Otherwise, they tend tend to deactivate the system, making the synthesis difficult. For example, in retrosynthetic analysis of 3-methyl 2,4-dinitro 6 tertiary butyl anisole, nitro group is a deactive disconnection in the first. And guideline 3, when function group interchange reactions are introduced in the retrosynthesis, the order of these reaction are determined considering the deactive directive influencing of the substituents. For example, in the synthesis of 4 trichloromethyl chlorobenzene from toluene ring chlorination followed by side chain chlorination is the appropriate order. Therefore, the retrosynthetic analysis presented in the scheme is correct. Side chain chlorination followed by the ring chlorination scheme 2 is not a right choice since trimethyl trichloromethyl group is meta acting and deactivating. And guideline 4, aromatic amine group is a very important in organic synthesis since it is highly ring activating and orthoparaditing. A variety of function groups can be conveniently introduced by functional group interchange reactions through diazotization, nucleophilic replacement of diazonium group by chlorine, bromine, and cyano group, and fluorine are some examples. Retrosynthesis of 2-chloro-biphenyl 4-carboxylic acid illustrated in this point. Guideline 5. Two ortho and para directing groups are isolated in the meta position and the aromatic ring cannot be introduced directly. Therefore, dummy amine group is introduced which directs the incoming nucleus electrophile into the required orientation. This dummy group can be removed later by diazotization and reduction. Following of the some of the examples are given for the retrosynthetic class of metachlorotoluene. Excellent. Guideline 6. Some substituents like hydroxyl, methoxy, phenyl are difficult to introducing in later stages of synthesis. Therefore, it is better to take starting materials considering these groups. For example, in the synthesis of 4-nitro-biphenyl is used as a starting material in, instead of attempting of phenylation of benzene derivative. Example is 4-nitro-biphenyl and 3-methyl 4-tertiary butyl anisole. Guideline 7. Examine the basic skeleton and combination of functional groups in the target molecule and such for a readily available starting materials which may have similar combination of the least few substituents. This will makes a synthesis easier and may afford an economic pathway to the target molecules. Some examples are easily available starting materials: salicylic salicylic acid, anthanic acid, thalic acid, phthalic anhydride, resorcinol, catechol, hydroquinone, orthocresol, orthoparametaxylene, metacresol, paracresol, biphenyl, and mescaline. Examples here: when salbutamol undergo under now that alcohol undergo primary alcohol undergo functional group interconversion can produces ester, and under after some retrosynthetic analysis, the side chain amine side chain is going to aldehyde, then gives uh, or orthohydroxy benzoate ester will be formed takes place. These are steps involved in the synthesis of salbutamol. Guideline 8. Synthetic sequences that lead to unwanted side reactions are to avoid. For example, avoid the attempt attempt titration when easily oxidizable groups such as aldehyde or halomethane groups are present in this system. Retrosynthetic analysis of 2 tertiary butyl amino methyl 4 nitro pentanol. Next, guideline 9. When both ortho and para substitutions are possible in the reaction and one isomer is required. It is better to block one of the position when if is blockage leads to deactivation of the ring. Let us consider the retrosynthetic analysis of di- dinocop A grading functionation as given. Two disconnections are possible. In disconnection A, electron withdrawing groups are removed, guideline B, but in the it is not appropriate disconnections since Friedel-Crafts alkylation of phenol with a bulky electrophile would yield 4,2-octyl phenol as the major product, which is not a required intermediate in the synthesis of dincopy. Intermediate disconnection of B is the nitration followed by alkylation of phenol is major. Like synthesis of alkenes, the synthesis of in the synthesis analysis of alkene, two most important reactions to be considered by are elimination reactions, dehydration and dehydrohalogenation, uh, and Wittig reaction. Alkenes can be prepared by dehydration of alcohols under acid condition. Therefore, dehydration transform can be used in the retrosynthesis of alkene. This alkene undergo dehydro transform, then gives alcohols undergo uh, trans retrosynthetic analysis, gives carbonyl compounds and Grignard reagents. And another method to synthesis of retrosynthesis of alkenes involves in the halogenation. This halogenation compounds are obtained from alcohols. Alcohols are obtained from epoxides when reacting the Grignard reagent. This is a Wittig transform reaction. Alkenes are undergo Wittig transform these carbonyl compounds and phosphorus. one group CX disconnection in compounds such as ethers, thioesters, alcohols, alcohols, and carbonyl derivatives, which carbon is attached to heteroatoms. Carbon is heteroatom. Bond disconnection is most appropriate in this type of disconnection. Carbon synthon is always positively electrophilic, and that of the heteroatom is a negative nucleophilic nature. Synthetic equivalent for carbocation carbon synthon are normally alkyl halides, acyl halides, or compounds containing good leaving groups such as tosylates, mesylates, and the synthetic equivalents for retrosynthetic analysis. Heteroatomic synthons are nucleophilic compounds such as alcohols and amines. Then alkyl halides undergo retrosynthetic analysis and carbon one group CX disconnection then gives carbon alkyl positive and halo negative charge. And also ethers also undergo uh, retrosynthetic analysis gives alkyl plus and RX minus will be formation takes place. So some examples are shown in below. These are some examples of one group CX disconnection of esters, amides. Consists of ethers, alkyl halides, and sulfides. A variety of aliphatic compounds such as ethers, alkyl halides, and thioethers, sulfides can be derived from alcohols, which in turns are obtained by carbon-carbon formation reactions. When alcohols undergo converted into alkyl halides, these alkyl halides involves in the uh, ethers when reaction with alcohols, and reaction with thioalcohols gives thioethers. When reacting with another nucleophiles by replacement of halogen atom. These are some of the examples are given in the uh, retrosynthetic analysis involving one group CX disconnection, nitration, bromination like azide, and ethers like this of the some of the one group CX disconnection compounds are given here. Next, two group CX disconnection. In this type of disconnection, one function group present in the molecule helps to disconnect the function groups present in the molecule. These are classified into three types. One is 1,1 difunctionalized compounds. In this 1,1 difunctionalized compounds, two function groups are presented to 1,1 carbon atom, same carbon atoms. These target molecules undergo disconnection takes place. That example is given here. Acetal. This acetal undergo a disconnection. These aldehyde and methanol. And the second example is alpha hydroxy cyano compounds, cyanohydrines. When the cyanohydrines undergo 1,1 disconnection, gives carbonyl compounds and cyanoic acid. And some examples are given in below. And 1,2 difunctional compounds. In 1,2 difunctional compounds containing two heteroatoms or adjacent carbons and can be considered as a derivative of alcohols. Most suitable disconnection gives a synthon which is equivalent to the epoxide or substituted epoxides. So examples are given here. The target molecule undergo disconnection. The gives epoxides. The epoxides involved in the nucleophilic opening of the ring, then gives the target molecule. And some examples are so there.
And 1,3-difunctional compounds. One-three-difunctional compounds. In this many 1,3-difunctional compounds are obtained by chemical addition of alpha-beta unsaturated carbonyl compounds, cyanides, and or nitro compounds. For example, if a nucleophilic group is present on beta position or to the carbonyl, cyano or nitro group, the most appropriate disconnection uh, would be bond connecting beta carbon to the nucleophile. So this is a 1,3-difunctional disconnection involved in the Michael addition reactions. For the below examples are given below.